Hello, everyone. Welcome to David versus LeetCode 150. Um, who am I, you ask? My name is David Wong. I am a software engineer currently looking for job opportunities in 2024. I'm currently pursuing a master's degree in software engineering at Carnegie Mellon University. I also have a bachelor's degree in computer science at the University of Michigan. If you want to connect with me on LinkedIn or through email, there we go. I have it on the screen. I'll also put it in the video description later. Yep, let's move on. So, what is LeetCode? LeetCode is basically a website for software engineering job interview preparations. LeetCode problems are basically puzzle-like interview questions. Just think of it as SAT problems for software engineers. And in all honesty, the actual job is going to be way harder than LeetCode. In fact, LeetCode isn't the only component to software engineering interviews. There's usually a system design portion, and there's another section where they ask you specific knowledge about technology. And there's also the behavioral interview where they ask you how would you collaborate with others, how you tackle difficult problems, and how you fit in well with the company's culture. Yeah, so in terms of the grand scheme of things, LeetCode isn't really that big, but it is a skill that you need to master as a software engineer. So, why am I doing this? Very obviously, it's for interview prep. I know it's time for me to look for jobs, and I gotta hone in on my LeetCode skills, so that's why I'm doing it. And also, just record the daily activity of a software engineer. Writing LeetCode is a thing that every software engineer does. In fact, there are 4.4 million software engineers in the United States. So this is a fairly common thing that isn't recorded. So I guess I'll be one of the few people to actually record myself doing these LeetCode problems and post it on YouTube. Also, just think of this video as a form of encouragement, because for newcomers to the LeetCode landscape, it could be really scary at times. But don't worry about it. Just practice, grind. You can do it. I'll show you the way. Not necessarily the way because I'm also preparing for the interview. But, if I could do it, then you can do it too. And let's see, the final reason, entertainment. Well, if you find it entertaining to see a person grinding LeetCode, then you're welcome. Normally, this kind of video isn't considered entertainment. Usually, videos are edited into digestible chunks. And if you're watching someone doing LeetCode, it's basically like watching paint dry. It isn't that entertaining. But if you find enjoyment in it, yeah, you're welcome. Now, in order to add some entertainment to this recording, I've made some rules for myself. So, for each problem, there is a 15-minute limit. I know that in most job interviews, they give you from 30 minutes to an hour to answer a LeetCode question. But since we're short on time here, we gotta try to finish these questions in 15 minutes. And for the definition of completion, I must come up with the optimal solution, both space-wise and time-wise. I'll also need to record my attempt on the spreadsheet, which I'm not showing here, but I assure you there's a spreadsheet on another window. Yeah, and let's see. So what should I do if I fail 3 questions in a row? Very simple. I'll play a very annoying royalty-free song to make the challenge more challenging. In fact, I have all the names of songs here. I'll show you in a minute. And if I pass 3 questions in a row, then I can finally stop playing that annoying music. All right. And is there a reward for completing all 150 questions? Yeah, I get to watch Madam Web tonight. I heard that's a pretty good movie. I'm also really excited to see it. So yeah, Here's a list of musical numbers that I'll be playing today as punishment, I guess. Some of them are fine, some of them are a little bit annoying, but it's entertaining, not the least. Oh, okay. So, here's a list of musical tracks. There's Fluffing a Duck, a Meatball Parade, Monkeys Spinning Monkeys. The list goes on and on. I guess we'll know. We'll see. Yeah, let's just start the challenge, all right? Okay, so I cleaned my entire history on LeetCode. So as you can see, there's no check mark, there's no check mark, no check marks, no check marks. Okay, let's try to finish the first section, which is array and strings. Here we go. Wait a second. I need to start the timer. Set 15 minutes. And here we go. Okay, first question. Merge sorted arrays. And just to be clear, for the sake of simplicity, I will just try to write down the answers without much explanation. If I could memorize it, have it memorized in my brain. On the actual interview, it is a two-way conversation. And remember, you have to keep the interviewer interested and invested. And if he or she loses track of what you're doing, then it's very unlikely that you will pass an interview. So, but for the purpose of just going through the list of questions today, I'll just write down my solution and the time and space complexity. Okay, so what's this question? Merge sorted arrays. You're given a two-integer arrays, numbers 1, 2, sorted in non-decreasing order. Yeah. Okay. Sometimes completing those problems comes down to having a good memory, because I think I have the solution to this clearly memorized in my brain. So here's what you do. There's the array 1, array 2, and since they're sorted, you'll just need to have 2 pointers, 1 point to the end of list 1, 1 point to the end of list 2, and then just start comparing the values, and then just copy and paste the value into the tail end of the list. It's pretty simple. Yep. So let's do it. Just modify the nums one and play. Great. Step 1. P1 is equal to, let's see, got M here, P2. Okay, so if we've already iterated to the end of P1, then we just write the value of, let's see, P2 to the end of nums1, nums1. If P2 Yeah, I know. The majority of this video is just me typing out stuff, so you're welcome. Let's see, P1 minus equal 1. Non-decreasing order. Yeah, how many do we have left? 8. Sure. Fine, 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 fine. Return. Oh, you don't need to return anything. Okay, let's check our logic here. Then both let's try to run this thing. P2 expected. Sorry. Totally forgot. Olive. Nums1, P1 is greater or equal to nums2, P2. Nums1, P1. What? That's strange. nums1 p1 is greater or equal to. Yeah, let's print out the pointers. This out of range. Let's take a look. How long is this array? Okay, this is kind of embarrassing. How many minutes? Ah, geez. 4 minutes left. Got it. Nice. Almost forgot. P2, P3 aren't the same. Yep. It just goes on to show you, you try to record yourself doing this, it does make the problem way harder, I think. Yeah, anxiety. Yeah, for software engineers, you gotta deal with anxiety sometimes. Oh, wait, let me pause. Okay, got it. Oh, I forgot to answer the time-space complexity. So, yep, the time complexity is O of n, where the n is the combined length of nums1 and nums2. And let's see, space, it is constant time, since you are not allocating extra memory to, the amount of extra memory that you are allocating is constant. You're not creating new arrays or something. Yeah, so yep. Let's check the solutions. Let's see, best solution here. Yep, linear time complexity. Yep, and then of 1. So yeah, we passed. Okay, let me write that down. Question number 88. I passed. How much time we have left? 3 minutes. And yeah, nice. Let's move on to the next question, shall we? Remove element. How do I tackle this problem? Let's see. Sorry. Let's just delete my solution here. Given an integer array nums and the integer val, remove all occurrences of val in place. The order of elements may be changed. Return number of the elements which are not equal to val. Oh, sure. This is a classic problem. It's another 2-pointer problem. So first of all, you have a pointer that takes care of iterating through the array. You have another pointer that writes the values you want to the array. And now what do we want? we want to remove all occurrences of value val. So that's pretty simple. We just have to do something like this. So here's I, W, and where's val? Val's go through 3. First, let's see, we'll have we go through a loop. First, we check if val, if the element is indeed the value we want to remove. If it is the value we want to remove, then we just don't care. We right through here, and if this is not the value we want to remove, then we just write the value in here and move the right pointer. Let's see. And then move here. This is not 3, so we could write it in here. Then move the right pointer along. And then let's see. We see a 3. It is not the value we want right in here, so we don't do anything with the right pointer. And then just return W, and you get your answer. So yeah, let's implement this. I for W is equal to 0 for I in range when nums range is not equal to val. Yep, you don't only write values into the array if your value is not equal to val. So yeah, well, let's try to run this. Yep, and the time and space complexity O of n space O of 1 submit, passed, nice, linear 1, yeah, I passed, nice. So let me have that written down. This is an easy one, isn't it? Okay, next one. Sorry if you were expecting a educational video on this, because this is just me running through the LeetCode list. This is not a tutorial video, so yeah, you're just gonna see me tackling these problems and coming up with the solutions. Well, what did I learn from this experience so far? Well, having someone watching you do these LeetCode problems is a much more challenging task than I expected, because there is pressure. You see, being watched. But no worries. This is probably what is expected of you during the interview. So I take this as a valuable experience where I can tackle problem solving when I'm being watched. So yeah. Okay, let's continue. Start the counter again. Okay, remove duplicates from the sorted array. There we go. That's the exact same problem as the last one. I think I even have the solution memorized inside my head. Basically, once again, you're given, you have to use a read pointer and a write pointer, and you just look at the value that's immediately before you to determine if you should write the value into your array or not. So yeah, let's try to implement this. W equals 0 for I in range len nums if No. You gotta go 1. If nums Yeah, I think that's it. Need to return the oh yeah, you also need to return W. And time linear space is also constant, not allocating memory based on the oh, there it is. Submit. Yep. Solution. Make sure that it is O of n, space constantly 1. Got it. Nice. Pause. Yep. 3 minutes. Nice. Oh. Let's move on to the next question. What do we have here? Remove duplicates from sort array 2. Okay, let's revert. At most twice. Okay, same question as the last one. It's just that this time you gotta look backwards 2 times. So you gotta look at both the previous number and the number 2 indices before your current number. So yeah. Let's try to write this solution. W is equal to 2 this time for I in range 2, len nums if yeah, let's test this out. IW, if not, okay, so definitely pass. Rewrite. 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 Yeah, I think it works. Let's run this. Time complexity. It's gonna be O of n space, once again, of 1 constant space, and let's just run this thing. Wrong answer. How's it wrong? Oh, forgot this should be num side instead of my. So here we go. Yep, got it. Let's go. Ba 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 bum bum. This is Orven. Yep, Orven. What's the number? 80. Nice. Yep, 3 minutes. Let's keep going. We're doing great. Hope that I'm not gonna listen to a copyright free music in the first hour of this challenge. Majority element. Let's just revert back. Linear time and Jesus. You know, sometimes solving these problems comes to just having a good memory, because if you do these problems long enough, you start to memorize them in your head. It should be a lot easier than you expect, since the whole reason came to the United States, or the whole reason I learned English at all, is that is because of Pokemon. Back then, in the old days, we didn't have the we only had the Japanese version of Pokemon in Taiwan, so I had to learn English to play Pokemon. Anyways, there's a total of 1,025 Pokemon in the Pokédex, and there's only about 1,500 problems. Or wait, is it 2,000 problems in the LeetCode database? So yeah, memorization does come in handy sometimes. But fine. I'll just write down the answer that I memorize. Okay. Here's a quick tip. During the actual interview, even if you have the whole solution memorized in your head, you gotta explain this to the interviewer, because the interviewer has to follow along, and if they don't follow along, then you don't pass the interview. That's how it is. But yeah, let's just spit this thing out, shall we? So the trick here is to just keep track of the number with the highest frequency. So for example, the highest frequency is first it was 3, and its frequency it is 1. And then if we encounter a number that is not the same value as this num, then we just decrease its frequency by 1. And then if it reaches 0, it means that there is some element with a higher frequency than the previous number we have. So that's when we replace it with another number, and then we replace its frequency with 1, and then we just see what happens. Oh, nice. So it's a 3. The frequency reaches back to 1. So yeah, hi freak. I forgot track of the time. Clear. Start over again. Hi freak number is equal to nums 0. Freak equals nums 1 for nums num in nums 1 sliced if high num is equal to high num else if and time and space complexity, linear time, constant space. Ah, there we go. There we go. Come on, come on, come on. Come on. Constant complexity of n. Yeah, but wait a sec. Majority element. Let's say I did pass this. It really depends. If the interview is a bit tricky, and they want you to answer like an alternate solution to this, then I definitely wouldn't pass this one. But do I count as a pass? Yeah, let's say pass. This one. Okay, pause. 3 minutes. Next one. Rotate array. Okay, classic problem. Fun trivia. If you use C++ for this interview, then you could use the rotate in place function to solve everything for you, and then just explain how the std rotate function works to the interviewer. Then you basically pass this question. But if you want to do it the hard way, then just follow along, shall we? So start the timer. So the trick to solving this problem is to just let's see. Just figure out the 2 segments you want to flip. You flip the first segment. You flip the second one. And then you flip the whole thing. That gives you the solution. Yeah, it's tricky. I'm not sure if there's another problem that involves you knowing this specific trick. You're very lucky if you figured this all out all on your own. But yeah, let's write down the answer. Okay. Len nums and let's write a little flip function. Yeah, and we're dividing k by the over the number of the length of the array, because it basically results to the same answer. Sorry, I do need practice explaining these concepts to you. Originally, I thought this this video would just be me talking about my life, how engineer thinks. But as you can see, when it comes to practicing LeetCode problems, it's just trying to figure out something on your own. Sometimes the thought process becomes a bit intuitive. For example, you don't really question how you walk forward, how you place your left foot before your right foot, and then your right foot before your left foot when you take the next step. It's this task will become autonomous eventually to you. So it is hard to explain a concept that seems so trivial to the human brain when you reach a certain point. But yeah. Oh, wait. Yeah. I'm on time limit. 4 minutes. Okay, let's just type in solution. Flip 0 len nums. Okay. Minus k. 1, 2, 3. Minus 1. No, I could and then just don't want to copy and paste len nums. This one. You don't need to return anything. Yeah, let's see if it works. Please. What's wrong? Just use the modulus operator. Yep. Dumb mistakes like this does happen when you're being observed. So the lesson here is to just practice with a actual human being, or record yourself when you're doing these LeetCode problems, because it's a totally different game when you're being watched. Okay. Oh, and yep. Submit. Okay, the time complexity is of n, linear time, space complexity, constant space. Let's see, do we have the correct solutions? Yep. Reversing, nice. Okay, 7 minutes. Great, 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 great. Ba 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 bum ba da bum 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 ba dum ba bum ba da bum 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 ba da bum ba da bum 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 bum. Okay. 1, 2, 3, 4, 5, 6. 6 out of 150. We still have a long way to go. That's another one. The solution stuck inside my head again. Basically, you just find the lowest value and the highest value. Make sure that the lowest value index is before the highest values, and then you get the solution. Let's just code this thing up, shall we? Min val is price is 0, and is equal to let's say 0 for p, and prices 1. Min val equals ands is equal to a max of ands, and p minus min val, the value before it, that's the lowest, and then update the minimum value to whatever the minimum value is now. Let's see, min ands min val p, return ands, then you get the solution. Yup. Then it's linear time. Oh no, linear time, constant space. Dun. Yup, got it. Yup, it's easy, but it shouldn't be easy because it's just a solution that I memorized in my head. 5 minutes. There. Next one. This is frustrating. I have the solution memorized in my head again. Getting rid of where price is the price, in stock. Maximize profit on a single day. Choose a different day. Let's see if this could be visualized. Let's see. Two, 3, 4. 1, 2, 3. Let's see. -6. 4, -2, 3, and -2. Let's see. Okay, let's think through this. So on the previous day, you buy it. Remember that for this problem, you gotta notice a specific pattern inside the graph. Buy on day 2, sell on day 5. Okay, I definitely forgot the solution to this, but still, we could try to solve it. Looking at the difference, figure out something. Let's see, -6. Profit or losses. How much? Oh, I see. It's just trying to find the previous maximum value and see if there's a difference. Okay, let's try to code this up. This is the wrong one. Let's see. Loss, gang, loss, 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 loss. Okay. I got it. That's strange. Okay, been stuck on this problem for too long, so yeah, I think I ran out of time. Check. Ah, dang it. Yep, ran out of time. The first problem to fail. Fail. Trick. Let's read through the trick. Single pass. Let's see. Instead of looking for a peak, followed by value with some go crawling up the slope, and ending a profit obtained from every consecutive transaction. Let's see. It goes down and up, and up, and up, and down. Wait a sec. Wait a sec. What? Oh. So that's the correct solution. Look at the previous element. If there's a gain, then there's a gain. There's no gain, no gain. Got 4, there's no gain. Okay. Yup. I failed this question. Yeah. Gonna memorize the trick. Remember to just let's see, there is yeah, okay, let's do the next one. Jump game. Just this one's easy. Just move the goal around. So you start with the goal, which is just the end of the array, and then for you just iterate backwards. If nums I plus nums I is where equal to goal is equal to I, means that it's reachable. Return goal is equal to 0. Linear time, constant space. Got that one memorized. Yeah. $55. Okay, let's do another one. Okay. Oh, come on, this is another one here where you have to kind of memorize the trick. The trick is that you don't jump until the last possible point you could jump. So, for example, you could jump. Okay, let's say after 2, you could reach here, and then let's say 3, you could reach here. Let's 1, 2, 3, 1, 1. So basically, it's just 2 jumps. Here's how it is. Reach. It's really strange. maximum reach. Maximum reach is the maximum of maximum reach, and yeah. And let's go through the problem again. I no jump, no jump. Now you know that you can reach that far. No jump, +1. Okay, I know it's a greedy solution, so let's start 2. You know that 2, you could start jump to here, so you keep track of that, and then you move on to here. You know that you gotta go this far, but is it the time to jump? No, you don't jump right away. You move to here. Know that you're at the end of the current jump, so yeah, of course you make the jump and make sure that your reaches here, and then you go to here and you discover that no, this does not contribute anything to your maximum reach. So yeah, so what's wrong with this? Nice. Okay, I'm just gonna add this to the fail ones. Yeah, couldn't solve it. Oh, you know what? I think more to make this feel more interesting. I should probably change the rules a bit. 3 failures, not in a row. Yep, the punishments come really soon, people. I'll just start playing that really annoying music once I get another fail, and then I'm gonna pass 3 questions to stop the music from playing. That'll make things more interesting here. So yeah. So let's take a look at how it's done. Yup. So first you'll figure out what's the maximum reach. If I is equal to the current end, wait a second. Maximum reach. So wait a sec. What's wrong with this? Maximum reach. Ah, I forgot. You don't get go that far. If it's an off by 1 error. You don't have to reach one pass. If you're at the end, then you're at the end. You don't need to jump back. So, yep. I missed I didn't pass this one because yep, I forgot that you only need to reach the end. Yep. Trick question. Okay. This is scary. If I fail one more question, then let's see. Yeah, fine. Let's fail 3 in a row. Yeah, let's put that back. I don't think. Yep. I don't think I'm failing 3 questions in a row. Yep. Oh, so okay. Let me put down some notes. Remember that you will only need to reach the fine position. Okay, let's move on to another one. H index. This one. Remember, you gotta sort the array. Sort the array and see what happens. 6, 5, 3, 1, 0, and then count. Just start counting. Yep, if you're at this point, it means that you have at least one book that's one citation. You have at least 2 books with 2 citations, at least 3 books with 3 citations. Yeah, got it. Yeah, citations. Usually the lists are called nums here, but citations. Yep, reverse equals true. Got it. Oh, then runtime and constant. Oh wait. It's it depends. It depends on the sorting algorithm. Sometimes Python uses quicksort, which would just it's gonna be like event time and constant pace, but most of the time, in terms of sorting, you would require you event extra space to perform merge sort. So it really depends on the internal implementation of the language. So yeah, this one varies. Let's take a look at sort. And log in. Counting. And space complexity. And log in. Counting accepted. Oh, let's say that I did pass. Although, if this question is indeed asked on the interview, they might ask you to try all different attempts, or you're lucky, your solution matches that with the interviewer. I mean, usually the interviewer knows the answer to all the different solutions to this questions, so it's really up to them. Yeah, I started to think that this shouldn't be that easy of a problem. It's medium, so yeah, it's fair. It's fair. In order to complete this problem, you at least need to know how to sort the array. Okay, here's what I observed from most of the problems on LeetCode. It usually involves hash maps or sorting. Sometimes you couldn't easily identify the pattern here, but once you see the pattern with sorting and hash maps, then yeah, it'll take you to the halfway point of the solution, I guess. Whatever. Well, that's I've been doing this for over an hour. How many questions do I have left? I'm not even sure if I could finish this in one day. Yeah, whatever. Time to get going. Another one, another one, another one. Good, 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 good. Yeah, this one I remember. It's just asking you if you know how to use the rand int. Let's see. So the itself dot r is equal to this. So dot map is equal to this. Yeah. Insert delete get random. It's basically asking you if you could attach a hash map onto an array. This sounds really strange, but is actually a super helpful data structure. I would say it's just a general approach when you're trying to do something crazy, such as insert delete get random. There's another question called are you cast to use like the same approach, but yeah, it's okay. You're this deep into the LeetCode interview landscape, you'll eventually encounter some weird patterns, and this is when you need to recognize them. This is like the one of the easier ones. But yeah, well, let's try to do this. I'll get some water. You know, I really want to watch Madam Web tonight. I don't think it's possible. Yeah, I kind of overestimated my ability to solve this fast. Okay, less complaining, more grinding. So, insert if val in self.map means that it's inserted, so just return. Oh. Remove. Okay, remove this tricky part. You gotta swap element with the back. Yeah. Yep, still got 9 minutes. Oh, wait a sec. Index is equal to so map. Insert 0, insert 1, remove 0. Let's see. Nice, got it. Oh, I totally forgot. Yeah, it has to be both ways. Remember, you need to update both the array and the hash map. So yeah, this is the data structures and algorithm interview. There's those edge cases you gotta look out for. Yeah, it's kind of frustrating to think that you know what a hash map does. It's you can insert items and pop it out in a constant time using but with the cost of using extra of linear space. But although the data structure makes sense to you, the application of such data structure is really confusing sometimes, and there's a lot more it can do with these data structures than you can ever possibly imagine. Yup. Let's just mark this one down. I finished this problem. Pass. Time used is roughly 10 minutes. Okay, next one. Ah, this one again. Problem array except self. Yeah, this one's easy. You got the first one, array, which is you just multiply everything from left to right. 2, 6, let's see, 24, and then another array. Do it run back. 4, 12, 24, and 24. Yeah. And then you just multiply everything from the left and everything from the right, and you get it. Yeah, that's pretty easy. Do. Nums high. Okay, what am I missing here? Got it. Yep. And based on the definition, constant space. Okay. So for this problem, time complexity is definitely O(n), but some definitions, space complexity is O(1) because you don't take the return value into account when calculating the what's called the space complexity. Yep, you don't take the return value into account. So yep, it's totally fine to define it as a having a constant space complexity. So you know what? Time complexity, space complexity, these concepts, do they really matter in the day-to-day job of software engineers? Usually, you think there's a performance issue. It's usually the problem of the language or the tools you're using. Um, it's really rare that you would. It's a problem with the a function as small as this one. So yeah, states and complexities can help us estimate how the runtime and usage of memory will grow, but in most cases, it only works in extreme cases where you think that there's actually a performance issue. I mean, always measure. Like before you measure the actual runtime, it doesn't really matter. So, yeah. I'm starting to think that doing these LeetCode problems really does turn reindeer the wrong way. Uh, I know these concepts are were usually taught in at universities, and but they don't go that far. These events puzzle like questions or something that you gotta learn on your own. This is a very niche skill. Is it useful in day to day job for as software engineers? You usually wouldn't tackle something like this. Okay, let me just write this down and tell you something. Uh, Ba-da-ba-bum. 10 minutes. Yeah, so I know at this point, you might think, what's the point of solving all of these problems? Yeah, so and the world of software engineering, I know that for every software engineer, there's like a different expertise. There are multiple different fields. You could go to front end dev, back end dev, machine learning. All each of these subfields require expertise in the tools you're using, and it is very unlikely that one of these subfields will give you an unfair advantage over data structure and algorithms. So yeah, in a way, this is a fair assessment. If you want to create a generalized exam test, that applies to all engineers. I mean, have you ever thought about how the SAT measures how well you do in college? I mean, college is really hard. It's much harder than what's tested on the SAT. So usually, I don't think we should really think about this. Just keep grinding, you know. Okay, gas station. Can I possibly finish the every question in 24 hours? I don't know. We'll see. Clear. Oh, gas station. Did this problem a few days ago. Really comes down to just practice, practice, practice. Memorize, 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 and train your brain muscle. Yep. I know none of this makes any sense, but trust me, if you practice long enough, if you stay consistent, all these concepts will become autonomous to you. It's like I call them brain muscles. If you work out every day, of course, there will be improvements. If you do a certain task every day, you will eventually get good at it. Even if it's something as niche as data structure and algorithms. So, yep, don't give up. Keep grinding. And gas station. Gas station. I've done gas station before. The trick to this problem is that there is only one correct solution. So if you see that, so for every other starting position, it is impossible to start at that position. And let's see if I can remember the solution. I started thinking that this is a really good question. Greedy problems. Greedy problems are the hardest. And then let's see. Just start writing. Dang it. Total sum equals 0. For sum. Yep, and the space complexity, time complexity, let's see. Okay. This might come down to the language, so probably zip. Yeah, if Python is concerned with its performance, then yeah, this shouldn't create like a totally new array of elements. it'll just be a wrapper around the for you to enumerate through the two arrays. So yep, it is constant. Okay, linear time, constant space. Yeah. So what's the lesson of this problem? If it's greedy, then and you know that only one solution works, then just move on to the next one. This is the core of the problem. Just move on to the next one. Assume that it's the correct one. Greedy solutions. It is hard to come up with to tackle greedy solutions. You just have to trust that the current solution is optimal in some way, and you don't need to backtrack to see if it is optimal. You have to put your faith into the algorithm. I know I couldn't figure this out. Jeez. Anyway, gas station. Gas station. Gas station. Gas station. Gas station. Woo! Let's do again. No, let's do another one. Candy. 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 Oh, I think I remember this. This is definitely LeetCode hard. Yeah, you got C. Okay, I know. I don't know the solution to this one. I only know like a sort of optimal solution where you scan one way and then back, and you require like extra space. But I remember that the solution requires you to do big O of 1, and I couldn't figure that out. So let's see if I could figure this thing out in 15 minutes. Woo! Candy! So the brute force solution would be to have like a for I and just go forth from the back. Candy. Candy. Whew, candy. Oh. Candy. It goes. Candy. Oh. Yeah, it'll be real nice if there's some candy over here, but I don't think we have candy. Okay, for I and range and Yep, and from what I remember, you gotta wrap the whole thing inside a function. So scan, start, and I forgot. Got it. Got it. Good. 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 I found solution. Yeah. Okay. Yeah, you didn't get it. I didn't get it. Oh. Scan. 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 Let's see. Yep, you're taller than that, and yeah, we don't care about that. And 3, you have to 3, 4. Let's use this as a test case. Okay. Here we go. So we do our first scan. Should bring you something like this. Oh man. Oh god, 4 minutes left. You know we will fail this one. Oh. Candy. Yep, higher. If I is greater than 1 and ratings I is greater than previous one, then what's this? Nice, nice, nice. Yep, I forgot. This statement would just overwrite whatever's okay. So in this scan, you gotta remember that there has been a updated value inside num's I. So yeah, just remember use max. And yeah, I did not pass because there's 1 minute left and there's no way I gotta figure out the O of 1 solution. So yeah, couldn't figure out this one. So failed, 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 failed. Candy. Candy. Just candy. Candy. Okay, let's do the next one. Trapping rainwater. Classic question. The intuitive solution would just be looking at the whatever the highest value is on the left and the highest value on the right, and then come up with something that come up with the solution. Usually this is a really hard one because you know what? Intuitively speaking, you might use the what's it called? The mono decreasing the mono stack approach, where you figure out what's the last the highest one. Oh wait, not the mono stack. You gotta figure out what the which number is how much how high the water can get in your current position. You gotta go all the way to the left and all the way to the right, and it will take what's it called? What's it called? Yep, it'll take linear space. But know that there's actually a trick that result in constant space, and let's see if I remember this. Oh, sorry, that's time for the last one. Okay, let's start again. If I fill this one and the median next one, there's no way I'm gonna fail Roman to integer. So yeah, we're not gonna play the annoying royalty free song that I have in the back. Yep. Uh, you know. Just okay. Well, let's start solving the problem. Yeah, well, no one's gonna play Meatball Parade here. Meatball Parade. Meatball Parade. Candy. 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 You know what? It's been 2 hours. I'm not sure if I finish this in one day, but let's see. I'll upload the first part to this recording on YouTube, I think. Woo! Woo! Candy. Okay, trapping rainwater isn't that hard. Whew. It's kind of cold in here. Oh, let me turn up the heat. I'll be back. I'll be back. Ooh. 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 Ho, 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 ho. Let's just call it HL and HR. Oh. Let's see. What's the edge? HL and HR. Oh, sorry. Oh, 6 minutes left. Okay. Okay, I think I don't remember the solution to this one. 2 minutes, 2 minutes. Okay, we still have time, still have time. When do we know when to move? Oh. Ah! Sorry, didn't get this one. Oh, man. Forgot which direction I should move. Fail, fail, fail. Well, let's do another one, shall we? Let's take a look at the solutions. How do you know when to move? Let's see. Yep. So it's determined by yeah, couldn't get this one. Yep, it's a. At the end of the day, it's a two-pointer solution, but yeah, we often think the two-pointer is something that's fairly easy, but no, this one extremely hard. Oh. Okay, no, don't worry. We're not gonna play the annoying copyright-free music unless we somehow manage to fail one of the easiest questions in the LeetCode library. It's just Roman integer. Good, good, good. And this one's pretty cool. I just need to memorize the rules. So first, let's just create a mapping for two values. First, just put them in the dictionary like this. Oh, sorry, I forgot to start the timer, but I think, yep, I think 5 minutes have passed. So yeah. If it's before, then there's a special rule that applies. Let's see what happens. If there's a 1, okay, 1 that goes for 5. Means it's actually 4. Remember that this is, yep, comma, comma, comma. Six instances where subtraction is used. X I V Yep. 5 more minutes. Oh. Nice, nice, nice. Got it. Yeah. Finally got it. Woo! This feels really good. Yup. Time complexity. O of n, where n is just a size of string, and then space complexity is constant space complexity because you're just allocating fixed amounts number of space for this problem. Yeah, it doesn't grow that much. Please don't tell me that it's like open space. Oh yeah. O of one. Ah, wait a second. O of one. O of one. Okay, this. Wait. No. Ah, O of one. Why is it O of one? Ah, great. A finite set of Roman numerals. Wait. A finite set of Roman numerals. Yeah, but it does mean that there is a limit to the how the function grows. So, yeah, I think that's it. I did. Wait a sec, but man, but still means I didn't correctly identify the time complexity because God, I failed. Like I didn't take that into account. Like I thought that the number of Roman numerals is infinite, and usually when you think about the input string, you don't really think about the upper limit, right? So yeah, this is a trick question. Although it's labeled as easy, it's not. It's not. It can be used to. It's a trick question. Yup. So, very unfortunately, I failed 3 questions in a row. I didn't correctly identify the time complexity. So yeah, here it is. It's the moment you've been waiting for. It's time to play a very annoying, maybe annoying soundtrack. I don't know. Here it is. Let's go. Okay, fluffing a duck. Fluffing a duck it is. Thank you, Roman numerals. You made me fluff a duck. Fluffing a duck. Okay. Yep. So I gotta. Yeah, I'm gonna listen to this soundtrack until I pass 3 questions in a row, which is. I really hope it's not that hard. Fluffing a duck. Fluffing a duck. Oh my god. This soundtrack is annoying. You know, it's usually used as background music, but from the perspective of the person in the video, it's usually non-diegetic. But in this case, this music is diegetic. I have to solve problems while listening to this repetitive soundtrack. Oh, dang it! I thought it couldn't be that hard to fail 3 times in a row, but there we go. Oh. I mean, the music isn't that bad. It's just it's really repetitive. It's repetitive boredom. Okay, just okay. Deal with it. You gotta deal with it. Let's solve another. Ah! Whoa! Oh God! Uh, what the hell's going on? Why is it so funny? I don't get it. Oh. Yeah. I think I need a break. Just give me a few minutes. Let me get some water and let's continue in 5 minutes, I guess. Fluffing a duck. Okay, sorry that I kept you waiting. Just got downstairs, got myself some soup. Oh yeah, yep. I got keep fluffing that duck. I mean, these are like the how do I put this? Okay, just here to share a quick story. About 2 years ago, I did attempt to wind through all these LeetCode problems. Back then, I was given a interview opportunity. They gave me like 4 weeks to prepare, so I did my best. I got myself Algo Expert Pro. This is not sponsored by Algo Expert. Just going through some of the problems. And back then, you don't need code. And he's really helpful. So I also went through his list, his tutorials, went through all the questions. Back then, if you could grind through the grind 75 list, you're good. And as for the questions I got on that interview, it was how will I say this? It was 2021, right? So for some reason, the questions were just the same. I don't know how to put this. It feels really strange when all three rounds of interview ask like the same question. There isn't a hard question in the interview. That made the interview really suspicious, but still, the difficulty of the interview depends on the company policy. So the best we could do here is to just practice and grind. Don't worry, this thing is easier than what you do on the actual job. I mean, on the actual job as an engineer, you'll have to design stuff. It's about communication and leadership and your expertise and knowledge in different tools. This is just puzzles, very basic problem solving, and all 4.4 million engineers in the United States do this. It's a rite of passage. I mean, usually, a regular person practices 2 problems a day. But no, what am I doing here? I'm trying to do the impossible. Try and review for any upcoming interview opportunities I get. I never thought that this could be entertaining. Wait a second. Let's see. How long is the music loop? It's an hour. So yeah, I could sit here and talk about how I grind through the problems. Okay, so if you are a beginner, go to LeetCode.io. There's a roadmap. Start from the easy ones and go to the medium ones, and just go from there, and you will start to understand the pattern. Not in terms of the just the general pattern itself. There's like sub patterns inside. Like binary search, you gotta know. I'll let you know when you eventually reach these problems. So yeah, these problems are like nothing compared to like most of the OAs nowadays. Usually they would send you like the link to a HackerRank coding question. Those are much harder than the ones here on level 75. Back in the old days, I mean 2 years ago, if you know these, you're good. But nowadays, this is like the easiest set of questions. Oh boy. Oh god. Let's refresh this thing. long way to go. So I think I'll upload like the first 4 hours of this LeetCode grind journey, and then I'll try to upload the second part. I really want to move on to the trees. The trees ones are fun. Backtracking, these are fun. Peeps. Bit manipulation, which why are we doing bit manipulation here? No, at school there's a course where they spend 2 full weeks teaching you how the bit manipulation works. Right shift, left shift, division, addition, and I'm doing this. Stop complaining. Just do the problem. And the Georgia Roman. It shouldn't be that hard. Okay, let's start the timer. Three, good. Let's see, what should I do? 58 minus 50 is 8. There's a 5. Subtract that. It leaves 3. 1, 1, 1. Good. 1994. How will we deal with that? Soup's pretty good. CM. Let's see. Let's match the symbols to the words. Uh, 11 minutes. MDCL XV high 1,500 100 50 10 5. So just iterate the whole thing and see what can subtract from the total value. I think that's the approach. And then there are these very tricky let's see, tricky pairs. So C for D, it gives you 400 900. Okay, that's really tricky. Sometimes I don't understand how these representations were defined in the Roman days, but it is what it is. Okay, don't get distracted. Gotta minutes left. Oh. nice. Good. Next side. It worked. Nice. Yep. So I totally forgot this mod. Shit. I don't think I've ever done this problem before. Okay. Time and space complexity. The time complexity is O of 1. Space complexity O of 1. Is that correct? Please tell me that it's just O of 1. O of 1. Nice. I finally passed. I passed. Just need to pass 2 more. And that'll be it. The end of this. I can finally stop listening to this weird song playing in the background. Oh, okay. Yeah. I should be doing more talking, less coding. Okay, the length of the last word. This one's easy. So, step 1. Find the last character. Find the white space before the character, before the word. Then you're done. sandwiches after I'm done with this. Maybe I should. You know what? I think I'll just order food for lunch today. Jesus. Jesus. Easy peasy lemon squeezy. Nice. Got it. Got this. 58. Pass. Use 3 minutes, I guess. Oh no. Okay, let's do this for another 30 minutes, and then I'll just upload this to YouTube, and start working on the next video. Longest common prefix. Oh, this one's easy. This one's really easy. Yeah, past, wait, time and space complexity. Time, let's say that it's m times n, where n is the number of strings and m is the length of the longest string. How much space will we be using here? It's just m, the length of the longest string, I think. Wait. Ideally, is it O of 1? Since you're returning the prefix, you don't need to allocate extra memory for this, right? This should be the correct solution. Yep. In this case, since we're not counting the return value into extra memory location, then the whole thing could be done in constant memory. So let's say constant memory. I just hope that the yes. Huh? Wait. What? There's a binary search solution to this? Oh my god! I'm not even passing this easy question. I couldn't come up with the binary search solution, so another fail. Oh god. Oh man, oh god. This is an easy question. Oh man, oh god, oh god, oh man, oh god, oh man, oh god, oh man, oh god. Let's just want to. I want to escape this music. Yeah, let's play from the start again. Reverse words in the string. Good. This one's easy. This one's gotta be easy. Hey, there it is. There it is. Yep, that's there's the trick. So, strings in Python, they are known as immutable data types. They're immutable and immutable. So for Immutables, there are strings and integer, floats, basically whatever data type that's usually has a size of less than 8 to 4 bytes. It's things that you wouldn't regularly use a pointer to point to. And as for wait, what is it called? Mutable types, it's okay, so strings are immutable in Python, so that justifies us not using the old one solution. So if that's the case, I'm just gonna do this. Oh, sorry. It should be joined by the space. Joined by the space. Reverse it. Reverse the string. Dang, just reverse. There it is. Time complexity O of n. Space complexity is also big O of n, because you couldn't mutate the string in Python. Yep, here we go. Yeah. O of n, nice! Finally passed. Alright. Okay, I just really want to escape this music. It's driving me insane. I mean, anything could. If you do something straight for 4 hours, it's gotta drive you insane in some way. If it's a really mundane task, shouldn't. In terms of solving puzzles, it should be intuitive for engineers. So, yep, don't worry. It's a rite of passage. Once you master all the data structures and algorithms and do coding problems every day, this is gonna be like a walk in the park. I'll show you. Okay, next one. Zigzag conversion. Oh boy. What's this? There are 4 rows. Okay, the first step to every new problem is to understand what the problem is saying. Good grief. On a given number of rows like this. So PAHNAPLSIIGYR. PayPal string. What's going on? I give a number of rows. There are 4. Okay. I think I know what it's doing. It's trying to write the string this way. Down, 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 up, up, and up, down, down, down. Oh, so we just need to figure out how many columns we need, right? Duh. Yeah, you don't need it. Wasn't even asking. What are you even asking? You know what? I don't get it. I don't get it. Fail. Anyone explain to me how? Was it even that? Oh, it goes down and up in a diagonal sense, but diagonally, yeah. Yeah, someday I'm gonna do these problems all over again, but oh god, this is a tricky one. Please don't tell me that it's asked by PayPal. Who's asking this? Oh, okay. PayPal. There it is. PayPal. Let's move on to the next one. Oh, the 2 pointers. Look, the 2 pointers are here. So yeah, we're almost done. I could probably escape this song in less than an hour, I think. Find the index of the first occurrence in the string. Give up. I know. This is an easy one. If you just compare the strings, I don't even need to write down solution for this one. It's a definite fail. You know what? I couldn't memorize this, but in terms of time and space, time, it's gotta be O of m times n, where m is the length of the haystack, and n is the length of the needle. Space, it's gonna be O1 because you're not allocating extra space. Wait a second. Let me think. You're not anything extra space. Yep. And this is the how you will normally solve it. You just keep matching and matching until you find where the needle is in the haystack. That's the intuitive solution. And the hard solution, it uses the KMP algorithm to speed things up, so that you don't need to start from the head of the needle. So for that one, the time complexity is m plus n. And space one is it's gotta be O of m, because you gotta record where you can start for each of the where you don't need repetition. This one is I don't think you usually need to use this one, but they might ask you. This is only useful when we have string of characters that are regularly repeated, but oh, so which one's the better one? How much space and time do we have? Okay, here it is. Here we go. From an engineer's perspective, you always prioritize time, because in real world, your boss wouldn't tell you to, hey, David, write this thing in a big O m plus n, or big O n times n. No, that's not how it works. You're just given the word faster. So if you couldn't do this one, then you basically failed the problem. Like, that's the it's just what I think. Although there's another argument saying that if this set of calculations, the runtime of the function, does not damage your product in such a way that it dissatisfies the customer, such that we're violating any of the what's called the non-functional requirements, then we're good, because we don't have time every day to argue over whether or not this it's worth it, like, so there should be like another way to do this, right? In the real world, when will you ever need to do something like this? Please leave a comment in the comment section. Let me know if you ever have to do this for a specific microservice or something. This task shouldn't be enveloped into a function, or maybe I'm just overthinking this. LeetCode problems are puzzles. They're not meant to simulate the real world. Every data structure you see here is condensed and simplified so that it can be represented in a string or like nodes. Like we'll talk about this when we reach the binary trees. But why would you load like an entire binary tree into memories? That's not what you do in real life. So yeah, it is. You'll need to learn these techniques for this interview. It's niche skill. Candy. Okay. Fine. Failed. Let's continue. Let's not waste time here. Text justification. This should be easier than the last one. Yeah. Let's start the timer then, right? It should be easier. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I mean, 7 minutes. We still have time. We still have time. Good, good, good. minutes. 2 minutes. Ah, dang it. Come on, I'm almost there. Dang it! Ah! Ah! Okay, I know. I failed. I just want to solve this one. I love this question. I actually like this question, actually. One, two, three, four. Yeah. One, two. One, two, three. One, two, three, four. One, two. One, two, one. Huh? Wait, what? Okay, I'll read the question right. Shall we? Huh? Wait, I don't get this. Oh, okay. I give up. I give up. This is a good question. It's just tricky. You just need to work your way through it. Yup, the whole intuition is to navigate through edge cases. This is a really good problem, I must say. I love this problem because this is not algorithmic. This is basically just asking you to follow the prompts and think of a way to separate the text, and you can actually do it in something like this. You can actually transform each line of text into like a row and apply some of your own logic to each row and generate the text. Yeah, this is like this is the easiest hard problem ever. I have to admit. I really want to finish solving this problem. It's so fun. I love this one. Nah, okay, I'll skip this. We should probably move on to the next question. But I have to say, this is my favorite problem I've seen so far. Yeah, I just hey, these are easy problems. I'm the solution to these problems. Okay, let's just finish them quickly so that I could just move on, right? I want to move on. What? Let's start. Nice, valid palindrome. Good. L. It's a 2-pointer problem. Let's go! Woohoo! Let's see. Move. Yeah, sorry guys. I'm just having trouble reading the problem. Okay, got it. Yeah. Okay, yep. O of n time complexity over 1 space complexity Just have 2 pointers. Just keep moving to the center. The only thing that it's testing you on is how to use 2 pointers and how to use is_al_num and how to use .lower, these operators, stuff like that. So yeah, let's just submit this thing. Got it. Yeah. Yeah, got it. Woo! Finally. Hey, true. Pass. Good. Palindrome. It's what's the number again? 125. Yep. It's sequence. Come on, just need to pass 2 more of them so I can escape this stupid music. It's sequence. Nice, got it. You're just trying to look for character and I inside the you gotta look for the character in S and T. So yep, easy peasy. Finally, a real easy problem. That's not a medium problem disguised as the easy problem. Oh, okay, yep. Linear time. Yup, linear time, constant space. I got this. Gonna finally escape. What's the name of some fluffing a duck? I am gonna. Wait. Continue. I'm gonna escape fluffing a duck. Fluffing a duck. It's gotta be easy. Nice. Subsequence. You know what? I'm probably not gonna finish all 150 problems today, but yeah, well, we'll see. I think I could at least hit like 100. I hope so. Well, this is gonna continue forever. You know, for most interviews these days, you gotta do over like I guess at least 500 LeetCode problems. I don't know. Oh, there it is. This one I was trying to show you. LRU cache. Sorry. Wait a sec. I've been stuck in fluffing a duck for over 90 minutes. Okay. I don't know what's the Okay, what's 3, 2, pass, and then final one. The final one. I can finally escape this. I could remember the solution to this. There's no way that I failed this question. This is like the second question that I gave you on LeetCode. It's guaranteed to have a solution. Numbers, yep. Nice. Time. Linear time. Space. Constant space. A two-pointer problem. A two-pointer problem. Yes! Finally! Woo! Woo! 3 consecutive passes. I have finally escaped from fluffing the duck. Oh. Oh. Oh God. Oh shoot. Oh. Oh man. Okay. Let's just upload what I have onto YouTube. We share it with everyone. And I'm not calling it a day here. There's still more to do. I mean, which problem are we on? We're at, what? 27? Oh God, we're still a long way ahead. Anyway, everyone, see you in a few hours. Let's continue with this LeetCode grind. And yeah, see you around.